This video is for adding and subtracting and multiplying matrices by scalar multiples. We're going to start with the definition. A matrix is a rectangular array of variables or constants in rows or columns. It is commonly written with brackets. An example of one would be 2, 3, -1, 2, 4, and 0. This is a matrix. It has elements, each value in the matrix, and it has dimensions. Dimensions are written by rows, by the columns. Specifically, this matrix have rows that go left to right and columns that go up and down. So we have 2 rows by 3 columns. Adding and subtracting, when you add and subtract matrices, the dimensions must be the same. And then you add or subtract corresponding elements. Scalar multiplication, you multiply every element in the matrix by a constant. Do not worry about commutative and associative property of matrices. And then when you're working on this, make sure that you remember that every matrix has a dimension. Rows go left to right, so we count down when we count our rows. Columns we count left to right, but it's the direction of going down. When we are performing the operations with these matrices, you're going to make sure that you line up values that are the same. So corresponding elements mean they are in the same relative location. So of these matrices, these values here line up and match or are similar locations of each other. This matrix's dimensions is a 1 by 3 as well as this one. So since those are the same, that's why everything corresponds. When you're going to get your answer, it'll be a 1 by 3 as well. And if you'd like, you can show your work. What you're going to do is you're going to take the first row, column 1 element, added the first row, column 1 element of the other. So you have -8 plus 11, 2 plus -7, and 6 plus 1. When you get done, your answer would be 3, -5, 7, and then you would have brackets around it. Now you can just jump down to this answer here, and I'll show you here on this next one. So corresponding locations. So what we're going to do is we're going to take each element, this is a 2 by 2, minus another 2 by 2, and we're going to just subtract them. So 7 minus 9 is -2, -12 minus 6 is -18, 15 minus 4 is 11, 4 minus a minus 9 is 13. So that is your answer. You have to make sure once again that your matrices are the exact same size, otherwise your elements will not correspond to another element. So on this next one here, once again, just going to perform the operation. So 5 minus a minus 2, 13 minus 18, -6 minus 8, 3 minus 2, -17 minus a -11 gives you -6. 2 minus 0 is 2. On this problem here, we have 2 columns, and then we have 3 rows. It's a 3 by 2. We have 3 rows by 1 column. We don't know if this column lines up with the first one or the second one. Since it's not the same dimension, it lines up with the first one because it's column 1. But there's not corresponding elements to the second set of numbers, so this matrix operation is not defined. In scalar multiplication, you just take the numbers on the outside and multiply it times the values on the inside, the elements. You are performing a dilation or just multiplying the values inside of it. So 3 times 4 is 12, minus 9, 30, 33, not 30, 33, 33, negative 30, 27, and 45. Remember to multiply every value. Gonna do it again with this matrix. It's a 3 by 3. Negative 30, 40, negative 60, negative 25, negative 60, 45, 0, 10, and 35. So that's the basics before we name matrices. So in the next section, you have matrices A, B, C, and D identified. So with these values, we have operations with numbers in front of the variables. So matrix B is the same thing as 8, negative 1, negative 2, 7, or we can call it matrix B. So we're going to take 4 times this matrix minus 2 times this matrix. It's just a nicer way to write out our information without having to use a bunch of space. So doing the operation, I'm going to take 4 times this matrix, get an answer. So I'm going to get 32, negative 4, negative 8, and 28. And then I'm going to minus, I'm going to take 2 times matrix A, get 12, negative 8, 6, and negative 10. So now that I have these two matrices written out, what I'm going to do is I'm just going to perform the subtraction. So 32 minus 12 is 20, negative 4 minus a minus 8 is 4, negative 8 minus 6 is negative 14, 28 minus a minus 10 is 38. On the next one, I'm going to do the same thing. I'm going to take negative 8 times matrix C, and matrix A, I should talk about this and I forgot to, is that these are all 2 by 2s, but this matrix here is a 2 by 3. So any operations with D are undefined or not defined. So C, the answer would be not defined because it doesn't meet the criteria of having the matrices being the same. So matrix C and A are the same dimensions, so I can perform the operation. Multiply first. So negative 8 times negative 4 is a positive 32. Negative 8 times negative 6 is 48. Negative 8 times 12 is a negative 96. Negative 8 times negative 7 is 56. And then 2 times A, which is this same matrix here, so I'm just going to write that one down. Otherwise I would perform the operations, and now I'm just going to combine the matrices. So I get 44, 40, negative 90, and 46.